So if we're going to talk about now the equilibrium part of the test, we better know those 5 ways to say equilibrium, right? So let's see, the first way is just the word. And I encourage you now to pause and think about what are the other 4 ways. The net forces are 0. Acceleration is 0. All balance forces. Constant velocity. This is another thing to have like at the top of your page. If you see a question on equilibrium, well then think about, you need to recall all 5 of these things. Okay, as you stay in equilibrium, okay, that's an important thing. On a bathroom scale, the downward force of your blank is balanced by the upward force we call blank. I think the word that they're looking for, the best word to put here, I think, is weight. You could have also said force of your body, force of, yeah, but weight is best. And the question is, what is the upward force? The upward force. It's the key word to tell me what should go in the blank. Well, this is called the normal force. Okay. The net force required to maintain a constant velocity. Well, hold on. They're saying constant velocity, so I'm not even going to read any further. Constant velocity, that's one of my equilibrium trigger words. Net force should be 0. So I'm going to have 0 in my brain unless something else about this sentence tells me it's a little more complicated than that. So the net force required to maintain constant velocity should be 0. Let me just think about that for a minute. For an astronaut in frictionless space is equal to what? So now this is just another way of saying, well, you're in a scenario, you're in a place where there aren't any other forces acting on you. So it's 0. I read further and it said, there's already someone pushing or pulling, or there's a lot of friction on you, then I would have to balance that force. I would have to balance that force somehow, but since there's no forces acting on it, net force is simply 0. Okay. The net force required to maintain a constant velocity for a box sliding across a floor it's still going to be 0. See, this is the same question asked another way. And it's asking about the net force. Now, if I were to draw a diagram here, now if I draw a diagram right here, this is talking about a box sliding across the floor. I'm going to say it's moving to the right. Now since it's on a surface, it's on a floor. If you're on the floor, you're on Earth. And so there's gravity working on you, right? But if you're on a floor and gravity's working on you, well, the floor is also pushing up. And so that's the weight or force of gravity. That is the normal force. And it's moving to the right, and no one's pushing it, right? No one's pushing it. There is some force going this way. It's a small force, but this is the friction force. Now, if the question said, what is the force required to keep it going at constant velocity? I would say it's equal to the friction force. But that's a different question. This question is saying, what is the net force? Well, the net force is always going to be 0. It's always going to be balanced. It's always going to be equal to the opposite. So the fact that the word net is here makes this a 0. And what that means is that you have this over here, pointing the other way. And now my net forces are 0, and now this can go at a constant velocity.